This video is about arithmetic and geometric sequences. This is AP Precalculus Topic 2.1. If you appreciate the content, please give it a like. Use the information below to write an equation for the following arithmetic sequences. Then find the 11th term of the sequence. In previous videos, we have learned that an arithmetic sequence can be modeled by this equation. an equals ak plus d times n minus k, where an represents the nth term of the sequence, ak represents term k, and d is the common difference. For this problem, we will let a4 represent the fourth term in the sequence. So when they say the fourth term is 7, that means a4 is equal to 7. If the ninth term is -3, that means a9 is equal to -3. We will substitute one of these for an and one of these for ak. I always like to let the higher index term be an out in the front. So let's let a9 equal a4 plus d, and now n minus k becomes 9 minus 4. But we know that a9 is -3, so we have -3 equals, and a4 is 7, plus 9 minus 4 is 5. I'm going to put that in the front now and call it 5d. Little algebra here. Subtracting 7 from both sides, we get -10 is equal to 5d. Dividing both sides by 5, we get d is equal to -2. Now that we know the common difference, we can go ahead and write the rule for an using a4 as ak and our brand new common difference for d. So a4, I'm going to go ahead and put 7, but just remember that this is a4, so k is 4. And then the common difference is -2, so I'm going to put -2 right now. And then it's time for n minus k, but that's going to be n minus 4 because the k is 4. So we have this. Let's go ahead and put a box around this because we were asked to find an equation for the arithmetic sequence, and this is it. Now we will go ahead and find the 11th term. The 11th term will be a11, and that will be given by 7 minus 2 times 11 minus 4. If you work that out, a11 turns out to be -7. Number 2 will be a bit easier because they gave us the common difference. When they say the second term is 5, we can let a2 equal 5 to represent that. So then we can go ahead and begin to write the rule for an. Let's put a2 in for ak. And then the common difference is 3. And then it's n minus k, in this case n minus 2. But a2 was 5, so the rule is an is equal to 5 plus 3 times n minus 2. This is the equation of the arithmetic sequence. Now we can go ahead and find a11, which will be 5 plus 3 times 11 minus 2. a11 works out to be 32. For number 3, we are given a graph. We can call this point right here a1 because of the 1 right here. And we can see that a1 is 7. And this point right here is a3. So a3 is 6. So we can tell what the common difference is going to be. The d value, when you're given a graph like this, is going to be the slope of the graph. So we can see that this is going down 1 and right 2. This is a slope of -1/2. So if you're very clever, you can tell that the d value is going to end up being -1/2. Now, if you didn't think of that, you could just calculate it as we did in the previous problem. So I am going to go ahead and do that. So using the formula, let's put A3 in for AN. So we get A3 equals, and let's put A1 in for AK. And that's going to be plus D times N minus K, so 3 minus 1. A3 was 6, and A1 was 7. And then 3 minus 1 is 2, so that'll be 2D. Subtracting 7 from both sides gives us negative 1 is equal to 2D. And sure enough, D, when you divide both sides by 2, is equal to negative 1/2. So you can sort of go through those calculations, or you can just take the slope off the graph to find the D. So now we have enough information to go ahead and write the equation. AN equals. Just pick one of these points to be your AK. I'm going to use the A1 to be my AK. And then plus D plus negative 1/2 is going to be minus 1/2. And then N minus K, so that's N minus 1. I'm running out of space, so I'm just going to erase the A1 and put in the 7. We know that A1 is 7. So guess what? This is the rule. This is the equation for the arithmetic sequence. And now we can find A11, which will be 7 minus 1/2 times 11 minus 1. 11 minus 1 is 10. Half of 10 is 5. 7 minus 5 is 2. So if I can just squeeze this in here, A11 is going to equal 2. So that's it for number 3. For the next 3 problems, we will use the information below to write an equation for the following geometric sequences. Then we will find the 8th term of the sequence. Here is the model for the nth term of a geometric sequence, where GK is term K and R is the common ratio. Number 4, the third term is 12. So let's let G3 equal 12, and the 6th term is 1.5. So we can say G6 is 1.5. Now let's fill these into the model for a geometric sequence. Again, I like to let the higher index term go in the front as Gn. So I'm going to write G6 is equal to G3 times the common ratio, and now the n minus k power will be 6 minus 3. So G6 was 1.5, G3 was 12, and then I have R to the 6 minus 3 is 3. So that's R to the third power. I don't want to have to use a calculator if I don't have to. So I know that 1.5 is 3/2. So I'm going to go ahead and write that so I don't have to use a calculator. Dividing both sides by 12 means if I want to divide 3 over 2 by 12, that's the same thing as 3 over 2 times 12. All right, dividing by 12 is the same as putting that 12 into the denominator with the 2. So that's going to be 3 over 24. And 3 over 24 reduces down to, 3 goes into itself once, and 3 goes into 24 8 times. So dividing both sides by 12, I'm going to get 1 over 8 is equal to r to the third power. Taking the cube root of both sides gives me r is equal to 1/2, because the cube root of 8 is 2, because 2 to the third power is 8. Now we can write the rule for Gn. Gn will equal Gk, so G3, times r, which is 1/2, to the n minus k power. So that'll be n minus 3 power. I'm running out of space, so I'm just going to erase the G3 and put 12 in its place. G3 is 12. So this is the rule for the geometric sequence. Now we can find, we are supposed to find the 8th term. So let's call that G8. So that's going to be 12 times 1/2 to the 8 minus 3 power. Of course, 8 minus 3 is 5, so that's 12 times 1/2 to the 5th power. 1 to the 5th power is still 1. 2 to the 5th power is 32. So this is going to be 12 times 1 over 32. So this is going to be 12 over 32. Dividing both of these by 4, we get 3 over 8. Kabam! Number 5, the first term is -3. So G1 is equal to -3. The 6th term is 96. So G6 is equal to 96. Let's put G6 in for Gn, and let's put G1 in for Gk. So we will get G6 is equal to G1 times r to the n minus k power. So that'll be the 6 minus 1 power. G6 is 96. So we have 96 is equal to G1, which is -3. And then this will be r to the 5th power. Let's divide both sides by -3. 96 divided by 3 is 32. So on the left side, we will get -32 is equal to r to the 5th power. Taking the cube, not the cube root, taking the 5th root of both sides, we will get -2. So r is equal to -2. By the way, please memorize that 2 to the 5th power is 32. That's how I knew that the 5th root of 32 would be 2. Now we can write the equation for Gn. We will leave G1 right here in the front, but now we know that r is -2. So we will have -2 to the n minus k power, so that'll be the n minus 1 power. But G1 is -3, so this is really -3 times -2 to the n minus 1 power. This is the equation for the geometric sequence. We can now use this equation to find the 8th term, G8. So this will be -3 times -2 to the 8 minus 1 power, which will be to the 7th power. -2 to the 7th power is -128. And -3 times -128 is 384. So that's the 8th term. For number 6, we are given the graph of a geometric sequence. I see 2 points that we can easily use. We are given G1, which is equal to 6. And we are given G2, which is equal to 3. Let's use these 2 terms to find r. Let's put G2 in for Gn, and we will put G1 in for Gk. So we have G2 is equal to G1 times R to the n minus k power. That's 2 minus 1 power. G2 is 3, and G1 is 6, and 2 minus 1 is 1, so this is just R. That means R is equal to 1/2. Dividing both sides by 6, we get 3 over 6, which is 1/2. Now that we know R, we can write the equation of the geometric sequence. Gn is equal to G1 times 1/2 to the n minus 1 power. G1 is 6, so I'm just going to swap that out real quick. And this is the equation. We can now use this equation to find the 8th term of the sequence. G8 will be 6 times 1/2 to the 8 minus 1 power, which is going to be to the 7th power. So we have G8 is equal to 6 times 2 to the 7th power is 128. So G8 is 3 over 64. Number 7. Scientists are studying the growth of a particular bacteria colony in a laboratory. The population of the bacteria colony can be modeled using a geometric sequence, where the first day of the study is day 1. The population on day 5 was 7,000 bacteria, and the population on day 8 was 32,000 bacteria. What is the population of the bacteria colony on day 7 based on the model? It's a geometric sequence, so we are going to use this model. The population on day 5 was 7,000. That means that G5 is 7,000. The population on day 8 was 32,000. So G8 is equal to 32,000. Let's put G8 in for Gn and G5 in for Gk. So we get G8 is equal to G5 times R to the 8 minus 5 power. This gives 32,000 equals 7,000 times R to the 3rd power. Dividing both sides by 7,000, the thousands will sort of cancel out, and we will be left with 32 over 7 is equal to R to the 3rd power. To get R by itself, let's think of it as raising both sides to the 1/3 power. That'll cancel out the 3. Now that we know R, we can write the equation for the geometric sequence. Just remember that Gk is G5, so K is 5. The equation will be Gn is equal to, and I'm going to just go ahead and write 7,000, but just remember K is 5. So then we have this R value, 32 over 7 to the 1/3 power. And then this will be raised to the n minus k power. When you raise a power to another power, you multiply. So I can just go ahead and multiply by n minus k, which in this case is n minus 5. We can use this model to find the population of the bacteria colony on day 7. So let's let n equal 7. 7 minus 5 is 2. So this will be 2/3. So we can write Gn is equal to 7,000 times 32 over 7 to the 2/3 power. This is the population of the bacteria colony on day 7 according to the model. So if we didn't have a calculator, we could just put this, and then the units are bacteria. If you do have a calculator, you can type it in. By the way, since we are representing the population on day 7, we should write G7 instead of Gn at this point. So the population on day 7 is 19,281.138 bacteria. You would probably round that to the nearest whole number if the directions said so. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.